So, well, my name is Carlos, and I'm gonna talk about an approach to the following problem. That is, how do you try to find vulnerabilities in software? How to try to fuzz software in the case you don't know the protocol. Okay, the software is using some proprietary protocol or an unknown protocol. What do you do then? Okay, so let's get down to business. Yeah, this is the agenda. So I'm gonna do a really quick introduction, just putting everything into place. I'm gonna talk a little bit about fuzzing, so a primer in fuzzing. I know it's like, oh, I don't know. Then I'm gonna tell why you need a different approach, because the problem is completely different. The approach I'm gonna take is a little bit naive, but anyway, it works for the demo. I think it's abusing the client in a client-server architecture. I'm gonna talk about the possible implementation that the name I gave to the code is Boyka. Does anybody know what Boyka is? Who Boyka is? That would be really fucked up if you know that. Very good. Afterwards, I'm gonna do an experiment. It's not a demo, it's an experiment, because I don't know if it's gonna work. And then really quick conclusion. So, who am I? Who am I? Well, that's me. I was born nerd. Yeah, this is Super Carlos. Then, of course, I studied particle physics as a good nerd, this crazy stuff. Then the prospective employers, they said like, what the fuck is that? I don't know. I don't care. Then I say, well, I think I'm gonna try my luck in Germany. Here I am. And somehow I managed to become the Prime Minister of Norway. Guys, Germany, land of the opportunities. So let's be clear from the beginning, okay, about the scope of this work. So you're thinking, wow, Carlos, you really know how to sell yourself. Yeah? You get some in job interviews, something like that. Okay, it's not shit. Yeah? It's like essentially flaw, so to say. It's a naive approach. You're gonna see the problems when I explain. There's gonna be a moment when you say, huh, and then there's a problem. It's pretty clear. But anyway, it's a really nice first approach to this problem. Okay. So just to give you some scope, yeah, what this is about. It's an interesting, or at least I think it's a really interesting approach to software testing. It's about touching things you're not supposed to. We all like that. So, yeah, it's about breaking stuff, only if you're lucky. And this is very important. There are a lot of references to pop culture. And I'm gonna make some questions, and there's gonna be chocolate. I have a lot of chocolate here. Just look for this icon. Yeah? There's going to be some icon here. I call it the Choco Quiz icon, and then I'm going to say, where's this movie, or something like that. And then you say the answer, and I give you chocolate. Okay. So you always need a disclaimer. You get it. Well, if it's too says it, then for educational purposes only, yeah? Don't do anything bad. So, fuzzing 101. Who here had some exposure to the topic of fuzzing already? Raise your hand, something like a lot of people, of course. So you may be thinking something like, pitch please. I really know this stuff, and I don't explain it. But anyway, it's really quick. It's like 5 minutes, and we need to put everybody up to speed. And it's really important to give some framework. Yeah? So really quick, this is my favorite definition, non-technical definition, of course. This is not mine. Why? Because fuzzing is, at the end, is some kind of brute force. And, yeah? This guy is Boyka, by the way. Have you seen the film? Very good that you didn't. It's a really crappy film. Anyway. How does Fasten usually works? Yeah, you can see here an example of the SALI framework, and for the well-known FTP protocol. Usually, you know the protocol. There's some kind of specification. You have to read everything, and you know how the protocol works. Then you can model the protocol. I mean, you know, for example, that there's some kind of packets that says user and space, and then a username. Then there are some other packets being sent through the network. Let's say a pass, a space, and then the password, etc. And then you know as well the order, so to say. Yeah? You know, you have to send first a packet that say user, and this is my username, and then the password, and not the other way around. So you know the dependencies between the parts of the protocol. Yeah? And this is usually how it works. You know the protocol, you make some model of the protocol, and then you say, okay, these parts, for example, this user, this big user, don't touch this because it's expected. But where the username comes, in this example, yo mama, then you can change it for, I don't know, 100 A's or something like that. You have to twist the protocol. Yeah? But this is the idea. You know the protocol. This is very important. That's why I'm repeating myself. Yeah? You know the protocol. You model the protocol. Why are you doing on your knees there? It's okay. I don't want to. Okay. Very important. You know the protocol. Okay. And then you model the protocol. And then you start sending packets. In this case, from a client to a server, in trying to break the server somehow. No? And then you wait, and it's a lot of time. Eh? Sending packets, thousands of packets. And then, if you're lucky, you're gonna bump into a crash. It's gonna crash. The server is gonna crash. You're of course monitoring the server as well. And then you're gonna say, oh, this has crashed. And then you're gonna try, because if it just crashes, it's not useful information. But if it crashes and you record as much information as possible about the state of the system when it crashed, then you can afterwards try to repeat with the same packet or the same status, the same crash, and maybe you can use it to build an exploit. Oh, chocolate quiz. Who's this guy? It's an easy one. Anyway, please, you can answer as well on the front row. So this is the point. You get as much information as you can from the state of this server at the time of the crash. Yeah? In this example, it is pretty easy to see that you can control some important registers on the CPU, values of these registers. So it's pretty easy to see that you can build an exploit using this crash. No? So you owned the server. Okay, sounds very cool. But there's always a but. Yeah? This guy says, yeah, okay, but what happens if you don't know the protocol? Think, for example, things like TeamViewer. Or things for Dameware. Do you know Dameware? This kind of systems where you have agents in every client, and then you have just an admin that has the software that communicates with all these clients. And they're using some kind of obscure give or take it protocol. Yeah? Everything is encrypted, everything is hashed, etc. And you don't know the protocol. You can always try to reverse everything, or you can take another approach. Yeah? What happens if you don't know the protocol? Drama. Yeah? I mean, there's no documentation, happens a lot, then, trauma, depression, all the, you know this very well. Maybe you can think really naive. I can always try dump fuzzing. That's the meaning is, okay, I don't know what this is. I just see bytes. This is like a blob of bytes, and I'm gonna just change bytes Yeah? So without knowledge, I'm going to take this 8 and I'm going to write a 7. Let's see what happens. Yeah? This is not going to work, of course. Yeah? You send this, then it's going to be rejected, and it's going to say, no, 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 no. This is not going to work. 2. Why? Just think about this really simple example. Very quick. You have a packet. This is very simple. You have a packet. A part of this packet is data. The other one is a checksum. Very, very easy protocol. And think about this checksum as some kind of SHA-1. Yeah? That means you have 160 bits. And you have to get them all right. I mean, the probability of getting this just by chance is 2. I mean, you have to get 1 in 2 to the 160. That is like 1 kilo tera. That's a lot. So you can do basically what you do with toilet paper with this method. So, does anybody want to solve? Which film? I don't know who said that. Throw it. Broadcast the chocolate. Okay, so we are a screw, apparently. So what do you think? Is everything lost? I can result to dumb fuzzing, but this is not going to work. It's going to take the age of the universe. Yeah, that would be really nice, eh? Because now I say, yeah, everything is lost. Okay, bye guys, thank you very much. And then you go drink something. Of course not, you need a different approach. Yeah? And now comes the sweetie moment of the presentation. Because I was thinking, how can I approach this problem? It's not a perfect solution, it's not even a solution, as you will see. But it's a really nice approach. So, let's be clear, guys. Okay, so then along came my wife. Yeah? Now I say, oh. Okay, this is my wife. Of course, she was really pissed. No, don't put that picture. Anyway, she is a biochemist. She has a PhD in biochemistry. It sounds like really cool stuff. She works doing protein, something with proteins. She's watching right now, I guess, the streaming from. Hi. What I suspect he really does is something like this. Yeah? Because he says, no, I do some foreign stuff with proteins. He does like zombies, dinosaurs, I'm pretty sure. But anyway, where's my wife here? Eh? Now I come to the point eventually. She was talking about this protein whatever thing, yeah? And then she was talking about bacteria and how you generate some synthetic proteins. This is going to be really quick. You don't need to know anything about proteins. I don't know either. And then she was talking and saying, actually, a bacteria is just a machine that generates proteins. Yeah? It has the information in the DNA. Yeah? It makes a copy of this information, and it has the machinery to create the proteins. So what they do is they change this DNA, some really, really small part, and they inject their own instructions, and then let the bacteria to generate, because that's the machine, to read this information and generate the protein itself. So something, they change a little part, and then this wrong information goes through this machine and generates the protein they want, yeah? Oops, oh, sorry, this is the end of the presentation. Man, sorry about that. I think it's something like this, oh, wow. Okay, sorry about that. So this is exactly what happens. So think about it. Then I was like, this is really interesting because the bacteria has all the machinery and knows how to create proteins. That's what I want. I just have to change the information and let the bacteria do the work. That sounds like really cool. Then I start thinking about this, everything is green. Okay. Oh, sorry. True? True? Okay, okay. Thank you very much. Yeah, exactly, I was fast in the cable. Okay, then I started thinking and I said, then I was in the mood for experimenting, yeah, because at the end, what the fuck can go wrong, yeah? So, who is this guy? I don't need the name, maybe the film, just the film? And what's the name of the guy? Oh, fuck, you're so good. You're very good. You as well. So, this is gonna end really bad. So, as I said, what the fuck can go wrong? Let's experiment a little bit. And the whole concept of this presentation, yeah, besides all the bad jokes, and it's exactly this. Because this is the problem. Yeah? This is exactly the problem. So I said, okay, the client knows the protocol. The client, the binary client, contains all the functions that generate the protocol. It takes my input. For example, let's say I want to log somewhere, then I write my login, and then this binary has inside the whole magic. And then it processes all this data. It generates some encryption, hashing, etc. It generates a packet and then sends it through the network. And this is exactly what I don't want to do. I just want to inject wrong information in the client and let the client do the work because he knows the protocol. Okay, so what is the procedure here? Yeah? Of course, this is not magic, so I have to analyze to a certain point this binary client. I have to take the binary and do some kind of reverse engineering and try to find, I'm going to talk a little bit later more specifically how, and try to find some interesting points, some points where they see, here is implementing the protocol, or at least here is taking my data and it's doing some kind of encryption. And it turns out it's easier than it looks like, because I mean, if you know a little bit of assembly and you see this stuff, you realize this is up to no good, because there's a lot of really funky assembly instructions. There should not be so many. Yeah? So, because I say so. I mean, you realize this is doing some kind of encryption hashing because it's playing with the bytes. Yeah. Okay. Yeah. So to say. Okay, you have to find those points that it looks like it's encrypting or hashing something. But moreover, you have to, another condition, so to say, to qualify for interesting points, is those functions have to be somehow near network functions. Because you realize that your data come here, then it goes along a lot of functions, somehow, somewhere, it's going to be encrypted, hashed, and afterwards this data is going to be in a packet and it's going to be sent through the network. Okay? Do you know actually why there's a graph here when I'm talking about binaries? Who knows about that? Okay, really quick. You can always, actually this is kind of a standard, you can always represent a binary with a graph, yeah? Those kind of rectangles are functions. Those arrows are, of course, the calls between the functions. That means that this yellow thing here, there's actually this function here. It looks pretty suspicious, but afterwards, it just called another function, and then it sends something through the network. It's pretty close to the network. So this is another kind of heuristic indicators. So, okay, this is pretty funky. I'm gonna try to concentrate here. Yeah? Okay, so then you say, I'm gonna check this function, and then you realize every function has some arguments. It takes some input. Yeah? Then I'm gonna check the arguments, and in this case, for example, there are some kind of a string of characters, and then a couple of numbers. This is really cool because this is easy to change. You realize you can change this, and maybe I'm not gonna break anything, maybe. It's more complicated when the arguments are really pointer to structures or whatever Windows stuff. So it's getting exciting. No. I'm getting excited. Because think about it. Then the problem, you have to, so to say, translate the problem in a way where you concentrate on the client software. You just take a look. You need to reverse everything. You need to understand everything. You just need to have some kind of feeling how this works. And then just try. Those functions look pretty interesting. I'm gonna try to change the arguments while the binary is running. I'm gonna change the arguments on the fly. So the binary is not gonna notice that, and it's gonna generate the packets. It's gonna do the encryption, the hashing, and all this funky stuff for me. I'm gonna send the packets. This is the idea, okay? So let's see what happens. What I use to achieve this then is basically two very important to huge platforms. One of them is Microsoft Detours. This is actually the most important thing, because this is hooking framework. This is really cool stuff. What it does is I can tell to Detours, okay, check this function. When this function receives some arguments, it gets called stop and do something. For example, I can extend the function itself and add new functionality. This actually, I think that is the original idea for Detours. Or I can even substitute the function completely. Yeah? This is a very cool thing. And another thing I used, and I'm going to talk very briefly about it later, is this Intel pin. Is by any chance Gal disking here? The Intel guy? The real Intel inside? Wow. No, he's not here. Cool. Because you were going to say, like, what the fuck are you talking about? It's not exactly that way. Okay, but I'm going to talk about pretty briefly. It's really cool stuff, but I'm going to talk about it later. So, yeah, this is just for the sake of completeness. This is just what I said before. Yeah? That's what Microsoft Detours does. So, this is, this is so broad, so to say, the possibilities, that we're going to try to just think of a little model here, yeah? Just to get some perspective. So what I'm going to try is this thing. I have the client software there. Think about something that's trying to log in to a server, huh? to have an idea in mind. I have this client software. It's talking to the server through this proprietary protocol. Okay, so this is exactly the problem, because this thing there, this is an overconfident developer. Yeah? He's thinking, well, what the fuck can go wrong? Yeah? Nobody can touch this stuff because nobody knows how it works. Yeah? So what they're thinking is, can't touch this. Yeah? But I don't want to touch this. I want to touch this thing on the right. I want to check I want to touch the client. So what happens if the client of the server is really not talking to the client, yeah? Or to a manipulated version of the client, okay? Now the developers are losing the cool. You can see they're like, what? Well, it turns out I can. I actually can. I'm gonna do it on the demo, experiment. And this is exactly what I want to do, yeah? And the developers are completely losing the cool, they're freaking out. So, long story short, this is the point. Yeah? The puppet here is the client. Okay, so this is just some kind of generalities. I'm going to tell you exactly how it works. Just give it or take it. Okay, this looks like, oh, but it's really easy, and this may be the most important slide. So think again on this example. I have client, I have the server. Okay, so this is what I did. I have two machines. Here's the server, and the server is really not that important because it's just gonna get the packets, process them, and hopefully crash them like hell. And there's the client software. That's why I wrote again. So this kind of graph. Yeah, those are some functions in this inside this client. Okay, then what I did is I wrote two small pieces of software. This is called Boyka Monitor, Boyka Console. There are basically two Win32 debuggers. Yeah? So I just took the API and I say, how do you write a Windows debugger? And it's actually pretty easy to write a debugger. And there are actually two debuggers that attached to this client and software, and manipulate them somehow. Yeah? And those two pieces of software, they're talking to each other through this communications module. Yeah? They're saying something like, I have to send a packet. Did it crash? No, I don't think so. Okay, I'm going to send another one. Or, whoa, it crashed. Then one of them says, log as much information as you can, etc. Yeah? Okay. Until here, everything is somehow clear. Okay. So what about the client software? This idea works, yeah? Because I mean the client is going to talk this protocol, and I can, without problems, hijack those functions and change the arguments. So injecting this wrong information. Remember this bacteria thing. Yeah? I'm changing the DNA and I'm letting it work with my information. This works, but then of course I try to do something else, and then I fuck it up. Okay. This is just some kind of zoom, yeah, of this client software stuff. Because then I thought, okay, how can I do this quick? That's what I wanted. Because remember, this fasten introduction at the beginning, you send a lot of packets. You don't send one packet. You send as many packets as you can, as fast as you can. So I thought, okay, think about this. This green function is actually the interesting one. Yeah? It's the one that you say, oh, this is doing some kind of encryption, some kind of hashing. This is the one you're hooking, and you're changing the arguments. But this function is not in the middle of nowhere. Yeah? What happens is a lot of functions get executed. They call each other, etc., they return. Some where this F2, the interesting one, gets executed, and usually it calls some other functions as well, or returns, and then other functions get called. I mean, it's just like a flow. Yeah? Then I realized that whatever happens before F1 and whatever happens after F3, it's really not interesting, yeah? Because, again, it's something like this. F1 gets executed, yeah? Then there's a lot more functions here in between, of course. That's those ... Then eventually this F2, oh man. Do you know how can I go to the last one? Yeah? Yeah? Okay. but I got it already. I'm gonna do it again, so we're gonna have time to try this. Okay, some functions are getting executed, yeah? Thousands of them. Then eventually, are those keys too close to each other? The F2 is gonna get executed. This is the really important one. I'm gonna change the values to whatever wrong values. Eventually, afterwards, it's gonna send the packet through the network, and then it's gonna keep doing other stuff, calling other functions. Yeah, it's gonna be something like this, really simplified. Then, what's really interesting is somehow what happens between this one and this one. Yeah? And then I said, and this is the very naive approach, and you're gonna see like, no, this is not gonna work. Then I thought, okay, I already have debuggers, so I can really do whatever I want with the binaries. Yeah? They're running under my control. So when it hits this F1 and F3, F1 and F3 are somehow arbitrary. Yeah? It's not a science. They're gonna save the whole state, like the VMware machine does. Yeah? I'm gonna save the whole state of the CPUs, the CPU, the flags, the memory. I'm gonna save everything. I'm gonna let it go. And when it hits the F3, I'm gonna restore the state. So eventually I see already some heads doing like, no. So eventually you're like closing this loop and just working between those two states. Yeah, that is the interesting thing. And think about it. Every time you hit F2, you change this to to different values. Yeah. Okay. This asterisk means, well, that works like it doesn't work. It works for the experiment. I think it works for really, really small pieces of software, but when you get to something really complicated with a lot of threads, etc., a lot of heap operations, it doesn't work. And once it crashes out 1,000 times, you realize, oh, now I know why. But okay, let's see what happens in the experiment. Yeah. Show. Fuck. Okay. You have to see the eyes. Sorry, it's just a little chocolate. It's not gonna. Okay, so the challenge. Yeah, we're getting close to the experiment. Yeah? That means I'm gonna talk a little bit less. So the challenge actually, is exactly this. So I was saying I can inject some data into the server. Why? Because I can inject some data into the client is going to process this and going to create valid packets and it's going to send it through the network. Okay? What's the question exactly? The question is, where is the question? Which points do I use? Yeah? I mean, the whole thing boils down to finding exactly what functions what exactly points you can modify. Who is this girl? Who is that girl? Whoa, who said that? What's the name of the actress? Which show? You're gonna get 3. It's the girl, save the cheerleader, save the world. It's okay. So this is exactly. This is exactly the problem. Yeah, the problem is, again, another graph. This is, I think, this is PuTTY, this SSH client. Yeah, we're talking about some pretty complicated stuff, but at the end, this is just 400 kilobytes exe. Yeah, and this is nothing. When you zoom this out, what you see is a line. So this is just so nothing in a line. I mean, this is incredibly complicated. The problem you have here is complexity. Yeah? Binaries are really, really complicated. So you need some kind of help here. Of course, you cannot do this manually. Okay, so a little bit of shameless auto-promotion. Who's this guy? Watch out! Who's this guy? Okay, well, the show? Game of Thrones, very cool. And sorry. Oh, no problem. Okay, so a long time ago, I wrote a plugin for IDA Pro, yeah, and it's in a perpetual beta state, yeah, and it has a very controversial name. It's actually a name after my license plate. True story. True story. True story. Guys, look at me. Do you think I can afford an Audi? No. Very good. So I wrote a plugin, and it's a kind of cute thing. Yeah, has some very nice features, and yeah, it helps a little bit with all this really tedious task and reverse engineering. Yeah? I can say, okay, give me all the functions that are connecting to send. For example, give me all the functions that connect to those functions, and I can sort of reconstruct this kind of trees I saw before. But it's a nice thing, but it's, as I say, the perpetual beta state. Now we're talking. If you want a really nice plugin for IDA Pro, if you're doing some kind of binary reverse engineering, you should definitely check out this. Where is Daniel Ploman? Do like this. Well, he's here, I know. And he wrote this stuff, and this is really awesome stuff. And the very cool thing is it has some kind of heuristics, and it can recognize the functions, say, okay, this looks like, for example, an CRC hashing. It looks like whatever kind of well-known encryption function. Yeah? This is a really cool thing. Or, well, I don't have that much time, unfortunately, so you can see this in the slides. It was just another method. I'm going to skip this thing because the experiment's more important. It was just another method to pinpoint which functions implement whatever functionality. Yeah, but it's I mean, it's kind of straightforward stuff. So you gotta build your own weapon. Yeah? You gotta take some framework and code a little bit, because it's too complicated, but there's a lot of frameworks and a lot of documentation. So, now, time to fight. Let's go to the experiment. Yeah? This, what is this doing here? Okay, this is my code. Remember I called Boyka, yeah? And this is the victim software. So, who do you think is going to win? Yep, that's right. So, this is again, but just for this particular example, what I said before. Eh? This is going to be the client. You're going to see it right now. I have two virtual machines. This is going to be the client. It's called Awesome Client, of course. And it's just a very, very simple thing. You just write some login there, whatever text. You click login, and then through the network connects or sends a packet to a server. Yeah, we're gonna see it. And okay, but this is implementing, of course, a proprietary unknown protocol. So, what I said before, you gotta take the binary, you gotta do some kind of reverse engineering. And for example, here I said, okay, here is my input. What I write here goes to this function. This here called assemble packet. Then this is going to do some kind of encryption, hashing, and then it's going to send it through the network. Yeah. And this function is appropriately called send the shit. So this assemble packet, yeah, of course I have symbols here. Sounds like really interesting. So I check this. And then I say, okay, so this function receives these 2 arguments. It's just a string. That's exactly the string I write as login, and then a number. So this is really easy to change, and it looks like it's not going to break. So let's do this. Yeah, I'm going to take my client. Sorry, this awesome client is talking with the server. It's using a proprietary protocol. I'm going to hijack this, and I'm going to change the arguments on the fly. Okay, but just very quick. The whole point is that you don't know the protocol. Yeah, but just for the demo to make a little bit more sense, I'm going to tell you a little bit how the protocol works. Yeah, so you can see what's happening. So the client is doing this. I'm going to write whatever login name. Yeah? It's going to calculate how long that is. Then it's going to check. It's going to take the login, for example, I don't know, Carlos, and it's going to append how long that is, 6 in this case, in ASCII. Just going to say Carlos 6, and then it's going to append whatever another string. It's not important, and it's going to encrypt everything. Then you're going to get bytes, scrambled bytes, and it's going to send this through the network. The server is going to decrypt this, and it's going to expect exactly this format. So it's going to say, okay, this is the login name. There are some kind of separators. Yeah? Okay, this is the length, etc. What is the server going to do? It's going to take the length from the client, and it's going to use it to malloc to reserve some space in memory, and then copy. And then you can already see. But if you do that, so who's this guy? Castle, very well. Sorry, watch the eyes. Okay, so let's do science. Who's this guy? Oh, you're such a nerd. But the good kind of nerds. That's no problem at all. Okay. So, sorry, didn't hurt anybody. Okay, unfortunately the resolution is not very good, so I'm gonna have to change back and forth, yeah? But it's okay, I think we're gonna make it. No. Okay. The resolution is really bad. Okay, I have 2 machines, yeah? This one red, because it's really bad. This one is the green. This one is the server. Yeah, the server is just listening there. Nothing is happening. He's very innocent. That's why it's green. This red is the very bad stuff. So here is this awesome client. Yeah, and then I wrote already some kind of. Then I'm gonna start the server on the other side. Here. Okay, so it's bound to whatever port. Cool. And then I'm gonna start. This resolution is killing me. Okay, I'm gonna start this Wireshark so I can see the packets. Yeah, so you can see that I'm not telling bullshit, or at least to a certain point. Okay, so I'm gonna try with this ACE. Yeah, this is my login. So do like this. This is, and I see here my server says, okay, there's some debugging here. I just received this whatever, and the length is 15. But what you see on the network is actually something like this. Yeah? So scrambled bytes. So you can see that if I send AAA, it gets BBB, and maybe if I send BBB, there's CCC there. So that's why I say, wow, it's some kind of encryption. But guys, it's an experiment, it's a demo for the sake of simplicity. So what happens if it just, this would be, for example, this very dumb fuzzing. What happens if I just start a TCP connection and I start sending bytes? Yeah? Gonna do like this, and then I'm gonna try to send, I don't care. Okay? Then let's see what happens here. The server says, of course, malformed packet. Because it's going to take these bytes, they're not following the protocol. Yeah? They're exactly, yeah? They're not following the protocol. So I have this malformed packet. Yeah? This is going to be rejected all the time. Yeah? Oh my God, 5 minutes. Okay, okay, I got it. You cannot do this. You're going to get rejected all the time. You want to go through. You want that the protocol is it's correct, so it gets correctly decrypted, and your data is getting inside the program. Yeah. So I don't need this anymore. So I'm going to do the following. I'm going to write something here. Yeah. And then I'm going to start the console part, yeah, on the right side. The other. Good. What this is doing, this is a debugger. Yeah? What this is doing is attaching to this, is looking for these interesting functions. Remember this assemble packet I said before? And it's going to attach to this function. And every time it gets hit, it's going to inject different data inside. Not the data I wrote here. Another data. Okay? Good. On the other side, it opens another port. Of course, this 1337, what were you expecting, just to communicate with the server side. Yeah? And they talk to each other and say, okay, it looks like it's working, nothing crashed, something crashed, or something like that. Just to do it really clean, I'm going to start the server again. And then I'm going to attach the second part. This is the part that is monitoring the server and looking for the crashes, and when it crashes, if it crashes, logging the information, and is talking to the other one, is coordinating. Okay? Cool. It's okay. Looks very good. And if this doesn't work, I'm going to be really sad. So I'm going to click login. It looks like it's working. What is happening right now? It's waiting like 1 second or something like that, just to keep some time on the other side to crash. Yeah? It's like, take your time, just crash. Don't. So what happens right now, it's moving between those 2 points the whole time. Because I set 2 breakpoints on those 2, F1 and F3, and it's moving, doing this memory on CPU snapshot all the time, and sending packets with the wrong credentials, with the wrong login. And you can see here that the protocol is right because you don't see any malformed packets. Yeah? It's really eating the packets as legitimate. Yeah? It says, seems legit. Okay, and it crashed already. It's very cool because sometimes it needs what? Wait. A really cool thing here is that it writes a mini dump, like when your Windows crashes, a mini dump file. So you can open it with Windows Debugger, for example, and then you have all your tools, your usual tools, and you see here, okay, it crashed here, and it crashed at this exactly direction, this point, and you see this question mark, so what is this direction? I don't know. Yeah? And by the way, what are you expecting the kind of crash? Because I told you before how it works, that it's doing some kind of malloc, and then it's doing some string copy. Not exactly. It can be a little bit more specific. It's some kind of overflow, of course, but exactly. It's a heap overflow because it's a malloc, yeah? So it's in the heap. So exactly. And yeah. So this is just to show off, yeah? Just so you say, okay, you're not telling any bullshit here, and exactly somehow it's going to say, okay, there is a problem here, exactly here, the heap is like linked to each other, so double link. So this command just checks if everything is okay, or there are some of the metadata is wrong. And you see here, okay, go to hell. And you see here this 3D61. It says this value is wrong. So the chain is broken. Yeah? And this 3D61, yeah? Damn it. Sorry, I was here. Exactly, here. You see that the memory address, when it crashes this 3D61, 3D61, and you say, okay, what is 3D61 in ASCII? And I just need 10 seconds. Yeah, so just wrote 3 lines of Python, so I can, Python is really cool. And then I said, yeah, tell me this D word, this 4 bytes word in ASCII. How does it look this in ASCII? Yeah, and it was 3D61, 3D61, wasn't it? Okay, and it says it looks like this. Yeah, and it was exactly what? Exactly this. So I didn't tell any bullshit 90% of the time. So it works. 1 minute? 1 minute too. So, wow, it worked. Okay, so somehow it works, at least for this demo. So exactly what do we need? Look at the responsibility. So what do we need to do? What do I need to do? Yeah, it's of course I need to think about better tools, or find better tools for the static dynamic analysis, just to find those spots really quick. Some kinds of some automatization, and yeah, I need to find those spots. That's the whole thing. Yeah. Okay, those are the interesting functions. And then, of course, this thing works here. But if you try some other software complicated, it crashes as hell. And so I'm going to move to another solution with full emulation. I was thinking about QEMU and this leaf-virt, this leaf virtualization. So I don't have 2 parts. I just have the whole system as a whole, and then I flip it. Yeah? And then I don't have these problems, and I want to say thank you very much to Pleat that told me, well, you're a moron, this is not going to work, never ever. But sometimes you need this. Well, everything, if you have interest, is online. You're going to see the slides, the address is there. There's my Twitter, there's my email. Well, and has been really nice, but maybe you have to scream now. I could understand.
Thank you. Thank you, Carlos. Okay, we have 8 or 8 minutes to take questions. Please do not exit at the back. Exit in front, please. I told you before.
Exit in front, and we can do like, yeah, yeah, yeah.
And if you're exiting while people are asking questions, please respect the question and answering session. Thank you. We will take questions. Do we have one from the Signal Angels? No IRC question? Yes? Do you have a microphone? We have one.
So there was a question on Twitter. Which one? This here? That's why you always add a hash of your message in any message-based post protocol and encrypt it afterwards. So there's not a really question, but
So just a suggestion.
Suggestion, yes.
Thank you very much. I'm gonna read it in Twitter because I didn't understand it very well right now.
If you have any questions, please queue up at the mics. Thank you. No questions, seriously?
It happens a lot. I get that all the time, don't worry. Anyway, I'm gonna be out there so we can maybe chat a little bit. You can buy me a beer.
There's one question from the left here.
If you have a complex handshake at the beginning, do you also reset the server and just skip the handshake part?
No, what I do, or at least the idea would be to expand where these F1 and F3 are, like open it like this. So you include the handshake inside this. So you include the handshake inside the whole process. So that would be exactly the idea.
So if you pass SSH, you would just do the handshake every time and get a different handshake key generation random number stuff.
I gotta say, pretty honest, I didn't think about SSH at all because this is like hell. But you're right, there's gonna be some other problems.
I'm sorry, but we have to cut the question and answering session short. Do you have anything? Everyone get out. Thank you.